last two lessons that we're going to cover today, lesson 3 and lesson 4, we're looking at the same types of things that we did in lesson 1 and lesson 2, where we looked at prisms and pyramids, except in a prism and a pyramid, the base should have straight line sides. So we had squares or triangles or trapezoids, something like that as our base. And these lessons, we're going to look at where we have circular bases. Right? Same procedures will follow, just some different formulas on them, but the formulas are actually very closely related to the other ones. I'm going to show you those relationships because remember, you do need to learn these volume formulas. So if you can learn the general idea of how the volume formula works, then it's a lot less to try to just memorize what seems like kind of random letters. So our formula for a cylinder has circles on top and bottom and stands straight up. So it's kind of like a prism, except it's round instead of straight line sides. The formula for volume says pi r squared h. Pi r squared is an area or a formula that we've had before, which is for the area of a circle. So in the last chapter we learned that pi r squared is area. So this really says then area times height, which is exactly the same thing as what the formula for prism says, area times height. Okay? So that formula still works, it's just that we have this specific area formula when we're talking about a circle of pi r squared, which is a formula that you learned in chapter 11. Okay? So if you can learn this big basic idea of area of base times height, then we could transfer that to other specific figures. The circle gives the pi r squared. Lateral area does not need to be memorized, but I like to show where it comes from because it's kind of a cool thing. So if I have a cylinder, and lateral area, remember, we're only thinking about the areas of the sides, not the top and the bottom. So I'm not thinking about like the circles on the top and bottom, not the cap or the bottom of this cylinder, but just the sides of it. So I can take a piece of paper and roll it into a cylinder, right? But then if I slice down that and unroll it, what do I get?
Rectangle.
A rectangle. Okay, so when I unroll a cylinder, the sides of it become a rectangle. Again, not worrying about the top and bottom, just worrying about the sides for lateral. So when we unroll it, the height of that rectangle is still the height of whatever the cylinder was. When it's rolled up, and when I unroll it, the height doesn't change, right? So the height is still height. Then this other part, the base, or the length, or whatever we want to call that, along the long side of our rectangle, when I roll it up to be a cylinder, what is that? The circumference of the circle. That's what's forming our circle. And in the last chapter, we learned that the formula for circumference is 2 pi r. And so then lateral area is 2 pi r, the circumference, times h, the height. Okay? You don't need to memorize that. I just like to show you where it comes from because I think it's kind of a cool little formula. And it is definitely something that could potentially show up on an ACT or something like that. So if you can kind of keep this visual in your head of like rolling and unrolling a piece of paper, then maybe you'll be able to recall it when you need it. But you don't need to memorize it for the quiz this week. So we're going to talk about cylinders today. We are also going to talk about cones today. A cone has a circle for its bottom, but instead of having a circle on the top, it comes to a point. So it's kind of like a pyramid. We talked about pyramids yesterday, where they come to a point. The formula for a pyramid was 1/3, and then area of base times height. So the same thing as the prism, but just 1/3 of that. And we talked about how it would take filling up a pyramid 3 times to be able to fill up the matching prism. Well, when we look at the formulas for cone and cylinder, we still have this pi r squared h, which was exactly the same thing as before, and we just put that 1/3 in front of it. Okay, so it's just like a pyramid. It's just got that 1/3 in front of it. Okay, just like a pyramid does. The lateral area formula for a cone, you don't need to memorize, and I'm not going to explain where that one comes from because there's a little bit more stuff that goes into that one, but that one's pi r s. Okay, where s is the slant height of the cone along the side of the cone, kind of thinking like the hill or, you know, sledding down the side or something. Not the height, not the straight up and down height, the slant height there. And then today we're also going to talk about spheres. A sphere is a perfectly round in every way figure, right? It's like a circle of circles. It's perfect. It doesn't have a base, okay, or a height. It's just all one big circle, but in 3 dimensions. The only measurement it has is a radius. The volume formula does need to be memorized, 4/3 pi r cubed. I don't have any nifty memory tricks for you. I can't really show you where it comes from without calculus, so you're just going to have to go with that one and put it on a flashcard and learn that one. 4/3 pi r cubed. Surface area, you do not need to have memorized. It is 4 pi r squared. For a sphere, we can't talk about lateral area because a sphere doesn't have sides and bases. It's just all one surface. So it just has this one type of area, which is surface area or total area. And that's 4 pi r squared, but you don't need to memorize that. If you're in biology, I know you worked with these formulas last week when you made some measurements on balloons and stuff like that. So they might look a little bit familiar from that. So we'll go ahead and scroll through to some example problems. In our first example, it says find the lateral area, total area, and volume of a cylinder. So a few things to find here. Oops. Working with a cylinder with a radius of 8 and a height of 10. The formula for lateral area, again, you do not need to memorize, but that is 2 pi r h.
What's the thing? What are the things we're
Volumes.
Only volume.
Volumes need to be memorized. So lateral area is then 2 pi, radius of 8, height of 10. And just like we did in chapter 11, we're going to calculate without the pi and then just let the pi tag along. So 2 times 8 times 10 gives 160, and then just let the pi tag along on that. Total area, we have talked about it a few times now as being a general idea. So on the formula sheet, there aren't formulas for total area. Total area is lateral plus the area of the bases. So total area is going to be the lateral plus, there are 2 bases to a cylinder because there's a top and a bottom and they're exactly the same. So I'm going to do 2 times, and since they are circles, their areas are pi r squared. Okay, so total area is always the lateral plus the bases. In this case, we have 2 of them because we have a top and a bottom, and they're circles, so pi r squared. So lateral we found is 160 pi. R we were given as 8. And again, we're going to calculate this just without the pi's. So I would do 160 plus 2 times 8 squared, which is 64. And I get 288, and I just let the pi tag along. I just calculate all the numbers without the pi and let the pi tag along. You don't square the pi? No, because we're not multiplying a pi times a pi, we're adding a pi to a pi. Volume formulas do need to be memorized. Volume as a general idea is the area of the base times the height. The base is a circle here, so pi r squared times the height. Our radius is 8 and our height is 10. And then calculate the numbers without the pi. So 8 squared is 64 times 10 is 640. And let the pi tag along. The next problem tells us the volume of a cylinder is 125 pi. Since it gave us volume, I'm going to start with the volume formula. Volume is pi r squared h, area of a circle times the height. Then the problem says, if r is equal to h, find r. So not always, but in this particular problem, the radius and the height are equal to each other. So what we can do is substitute one for the other one. So instead of using two letters in this problem, I'm going to take that h and swap it out for an r, since radius and height are equal to each other anyway. So then I have 125 pi is equal to pi. If I have an r squared and another r, what do I get?
R cubed.
An r cubed. I'm going to divide both sides by pi to just get rid of those, and I have 125 equals r cubed. R cubed means that I'm multiplying something times itself 3 times, and it should equal 125. And I don't expect you to know your perfect cubes, so you just grab a calculator and start trying some stuff out. 3 times 3 times 3. Nope. 4 times 4 times 4. Nope. 5 times 5 times 5. That's 125. So our radius is equal to 5. Okay, I don't expect you to know your perfect cubes, so you just grab a calculator and start guessing and checking. They will be nice, clean numbers, so you'll be able to do that, and they'll be pretty small numbers, so hopefully it won't take you too many guesses to get to the right value. All right, those two questions are cylinder questions. Any questions on those two problems? Okay, so the next example goes on to a cone. So we want to find our slant height, lateral, total, and volume of a cone that has a radius of 4 and a height of 3. When I draw in that radius and height in the picture, what do you see?
Triangle. Right triangle.
A right triangle shows up. And if I have one side that is 3 and one side is 4, then the other side is going to be 5. So that's our slant height, and that's the answer to our first question. The second thing then says to find the lateral area. Lateral area is pi rs. That's pi times a radius of 4 and a slant height of 5, which gives us 20 pi. Total is lateral area plus the area of the bases. A cone only has one base because it has a circle on the bottom, but then at the top it just comes to a point. So I just need 1 pi r squared here. Okay. When we did the cylinder, we did 2 pi r squared because there was a circle on the top and a circle on the bottom. For our cone, there's only one circle in it, so we just need 1 pi r squared to it. So we get 20 pi plus pi times 4 squared. 4 squared is 16, and add that to 20, and we get 36, and the pi just tags along.
Can you see 20 times 4 squared?
20 plus 4 squared. Volume, we learned yesterday that for a pyramid, when we come to a point, we only get 1/3 of the volume of if it were a prism. Same thing with a cone. We only get 1/3 of the volume of if it were a cylinder. So we do 1/3 the cylinder volume, which is the circle, pi r squared, times the height. So I really like ice cream, and I don't know why we always use ice cream cones. I think it's just like ice cream cylinders because we get 3 times as much ice cream. That seems like a good thing to me. So I don't know what the big deal is with cones.
That's
But pop comes in a cylinder, right? And we do all right with that.
Yeah.
Like I can handle a cylinder of ice cream. I think I can handle it.
It's easier to lick out of a cone though.
Yeah.
No, you have to eat
That's
the
true,
cylinder
I
down.
guess, because otherwise it's gonna like melt down into the bottom and then you need to drink it.
That's why you give they give you a spoon.
It'd be
with
fine.
it.
Just
Screw
1/3.
with it then. Yeah. I guess then we're just basically eating Ben and Jerry's,
Then-
right?
then
Like at that point
it's-
we're just eating a tub of ice cream, which I'm okay with too. I'm not above
Then
that.
it's just a bowl.
I'm not above that.
It's not. Oh,
But it's 3 times as much.
yeah.
Alright, so then I plug in my radius of 4 and my height of 3. And we can calculate those numbers through there. Again, you can just do this on your calculator. 1/3 times 4 squared times 3. Just ignore the pi, and that turns out to be 16. And then just let that pi tag along.
I said that before you.
Said it before we had the conversation about ice cream.
Make sure you don't take their box of ice cream.
Number 4 asks us to find the height and slant height, lateral and total, of a cone with a radius of 9 and a volume of 324 pi. So since we're given volume, that's what we're going to start with as our volume formula. So the volume formula for a cone is 1/3 a circle, pi r squared, times the height. So 324 pi is equal to 1/3 pi. The radius we were given is 9, but we weren't given the height. So we can use this equation to solve for our height then. I'm going to begin by dividing a pi off of both sides. So on both sides, just divide it off and that's gone. How do I get rid of the 1/3? Multiply both sides by 3. So I get 324 times 3, which is more than I can handle in my head. So I get 972
Hopefully you got that right.
is 81h. And divide that out by 81, and I get 12 for my height. So the first thing we're asked to find is our height. We just found a height of 12. Then we're asked to find slant height. Slant height, we get this right triangle again. So we could do Pythagorean theorem on this guy. 9 squared plus 12 squared equals s squared, and that would give it to us. This is actually a special triangle too, but you probably don't recognize it as being one. If I take a 3, 4, 5 triangle, I can multiply those sides by anything I want, and it's just blowing up the triangle to make a bigger one. So if I take 3 and I multiply it by 3, I get 9. If I take 4 and multiply it by 3, I get 12. So this triangle is 3 times as big, which means that third side would be 15. If you notice that, it's maybe a little bit quicker than doing the Pythagorean theorem. If you don't notice that, the Pythagorean theorem is always a good way to solve the right triangle. So we get a slant height of 15 on this one.
It doesn't matter whether the 3 and the 4 are. It doesn't matter whether they go 3 and 4.
They just have to be the legs. It can be the hypotenuse, but it doesn't matter which one is the vertical and the horizontal. Then we're asked to find lateral. Lateral area is pi rs. Can you spread down a little bit, please? Pi rs for our lateral area, so pi, our radius is 9, and we just found a slant height of 15. So 9 times 15 is 135. And the pi just tags along. And then the last thing here, total area. We do our lateral plus the base, which is pi r squared, or pi 9 squared. So we do 81 plus 135, just ignore the pi's and let them tag along. We get 216 pi. Questions?
Is this like the last lesson? What do you think is that from yours?
Yeah, it's like the last lesson, just different formulas. Yep. Yep, in the last lesson they were pyramids, so they had straight side bottoms, and now they have circle bottoms. But it's the same thing, just new formulas. Those two questions are about cones, and then we're going to move on to the next question. Any questions about cones?
Sphere. How do you draw a sphere?
Okay, so our last questions are about spheres. I don't find it particularly useful actually to draw a picture of a sphere because the sphere only has one measurement. So like labeling it isn't really that big of a deal. There's not that much to see in a picture of a sphere that will help us solve something. Whereas in a cone, when we draw it, we can then see that right triangle that occurs. A sphere is not particularly helpful to draw. So the area formula does not need to be memorized. It is 4 pi r squared. Our radius is 3. We get 36 pi. Volume does need to be memorized. 4/3 pi r cubed. Again, I don't have any great memory trick on that one because it takes calculus to figure out where that comes from. So that one just have to work on memorizing. 4/3 pi, our radius is 3. And you can type that in a calculator and you end up getting 36, and the pi just tags along. This is one very special specific case where the area is the same as the volume. That is not generally true. Okay, so don't believe that to be a pattern that you can just find one and it will be the other. That only happens specifically when the radius is 3.
Sorry. Could you like write the answer as like 36 and like multiply that by pi and then leave it as decimal?
Yeah, you could like type it into the pi in your calculator or do 3.14 or something, and that would be a correct approximation. When we leave the pi in, it is a perfect answer, and it's just a little bit cleaner and easier to write. The next one says find the radius and volume of a sphere with an area of 16 pi. So since it gave me area, we're going to start with the area formula, 4 pi r squared. I can begin by dividing both sides of this by 4 pi. All the pi's cancel out, and I end up with 16 over 4, which is 4. And on the other side, just an r squared. So I get a radius of 2. Then we are asked to find volume. Volume is 4/3 pi r cubed. So we plug the r in. Now when you work this out, we can think about this as being like over 1, right? Because anything can go over 1 and it doesn't change it. So 2 times 2 times 2 is 8. When you multiply fractions, you multiply the top. So 8 times 4 is 32. That does not divide evenly by 3. So we're just going to leave it as 32 divided by 3 and then let the pi tag along. We actually do that 32 divided by 3, we get a long repeating decimal, which we don't really want to round off. So it's best to just leave it as a fraction when it doesn't go in evenly.
How do you know it's a repeating decimal?
Because it's a third.
Oh, yeah.
So it'll be 0.3 or 0.6. Number 7. Number 7, we're given a volume of 23. Pen's failing for the last problem here. 2304 pi. And so we'll start out with our volume formula then. Just 4/3 pi r cubed.
It's the Earth, guys.
So I can start out by canceling those pi's on both sides, divide both sides by pi. How do I get rid of that 4/3? Multiply by the reciprocal, which is 3/4. So that cancels that whole fraction, but if I do it on one side, I have to do it on the other side as well. So I'm going to multiply 2304 by 3/4. I don't know what that is.
Sure. How long would it take you to do it out?
It's not worth it. 1728 is equal to r cubed. Okay, so remember I said I don't expect you to know your perfect cubes. I actually don't know this perfect cube. So what this means is there's some number that I can multiply 3 times, and it should be equal to 1728. So that's pretty big. So I'm going to say 10. Okay, 10 times 10 times 10, that's 1,000. So it must be bigger than that. 11 times 11 times 11. I don't know what that is, but it's not this. 12 times 12 times 12 will do it. So you just do some guess and check until you get there.
Not too big of a radius.
It's actually not a huge radius, no.
Bigger.
Numbers get pretty big pretty fast when you cube them. Then the last part of this problem asks us to find our area. Area is 4 pi r squared. So 4 pi 12 squared. So we do 144 times 4, which is 576. And the pi tags along. Okay. Your homework is the problems both from section 3 and from section 4 for tonight.